Good afternoon or morning, everyone. So today we're going to discuss solving quadratics by factoring. So if you hadn't noticed at this point, if you've ever found yourself with an equation that looked like this, x squared minus 4x plus 7 equals 0, you do not yet have the technique to solve this type of equation with just Algebra 1 knowledge. One thing I've seen people try to do unsuccessfully is something like if you subtract the 7 from both sides, so x squared minus 4x equals negative 7, and then like try to put a square root on both sides. This doesn't work, right? The square root doesn't cancel out with the squared here. I can't combine the x squared with the 4x. So this one tool that you've had for solving equations your whole life no longer works on this type of equation. So for this, finally, you get to add a new tool to your tool bag when it comes to solving equations. So what we do is we use a technique called factoring. So to see why it's useful, take a look at this equation here. X minus 3 times 4x plus 1 equals 0. So I have two things multiplied together equals 0. And we know from, math that if two numbers together multiply to 0, then one of those numbers has to be 0, right? So here, to solve this equation, so if x minus 3 times 4x plus 1 equals 0, then this expression equals 0 if either x minus 3 equals 0 or if 4x plus 1 equals 0. So we're allowed to split this equation into two smaller and easier equations. And we could see that the solutions to that equation would be x equals 3 and x equals negative 1/4. And looking back at this original equation, we can see that that works. If x is 3, then 3 minus 3 is 0, and 0 times whatever this is would be 0. Or if we plug in negative 1/4, then 4 times negative 1/4 plus 1 is 0. 0 times whatever this is 0. So this is going to be the tool we use to solve equations that are of this form. So now the question is, how do we get it to that form? So first, let's talk about what factoring means. When we factor an expression, we're breaking it down into simpler expressions that, when multiplied together, form the original expression. Just like if you were to factor a number, like 6 is equal to 2 times 3, right? Or, so when you factor a number, you're breaking it down into smaller numbers that multiply together to make the original number. When we factor an expression, the same thing. We're breaking an expression down into smaller and simpler expressions. So I mentioned, I think last class, that you've been trained your whole life when you see these two binomials multiplied, you want to FOIL it, right? It's like you just want to FOIL it. It's what you do. But in fact, what we're learning today is usually going this way is more helpful than going the other way. Sometimes we have to FOIL and then do other things, but most of the time it's more helpful to have this expression than the one on the right. So we'll start with the most basic kind of factoring. Factoring the greatest common factor out. So if we have an expression here, so notice when we factor, it's like we're undistributing, right? So here, with 16x squared plus 8x equals 0, both of these terms have an x in them. And in fact, they're both divisible by 8x. So if I factor out an 8x, and I'm distributing, like I'm reverse distributing. So what would I multiply 8x by to get 16x squared? And it would be 2x. 8x times 2x would be 16x squared. And 8x times 1 would be 8x. And now I have it broken down into two factors. So the solutions to this equation would be whenever 8x is equal to 0, or whenever 2x plus 1 is equal to 0. So my solutions are x equals 0 and x equals -1/2. Subtract 1, divide by 2. All right. Here we have x squared equals 11x. One question I get a lot with equations like this is, can we divide both sides by x? And the answer is yes, kind of, not really. What happens if you divide both sides by x, and you could do the same thing on this equation, is you'll no longer realize that x equals 0 is a solution. So it's better to just get in the hang of factoring these things. Now notice, if we're solving by factoring, we need to have the equation equal to 0 first. So that means we have to rearrange terms so that one side is 0. So here I want to get 11x on the left side. So it's x squared minus 11x equals 0. And then this would equal 0, so I can factor out an x, and I get x times x minus 11, which means that x equals 0, or x minus 11 equals 0, so x is equal to 11. So that covers, this is the most basic case of factoring, and often the most forgotten one as you learn more factoring. So here we get to the more fun ones. So consider if we had, because when we factor we're unfoiling, right? So it helps, let's look at what happens when we FOIL something. So x plus p times x plus q. If we FOIL this out, we would get x squared plus qx plus px plus pq. And if I were to take these two things, and one way to look at this is that these are like terms, sort of. They're both x and x. So whatever p and q were, this would end up equaling p plus q times x. So notice the resulting, when it's FOILed out, we have x squared times p plus q x plus p times q. So in order to go the other way, we have to find what these two numbers are. So in order to factor something x squared plus bx plus c, we have to find two numbers, p and q, such that p plus q is the middle coefficient, and p times q is the constant term. So to factor x squared plus 6x plus 5, I need to find two numbers that multiply to 5 and add to 6. So I'm going to list out all the things that multiply to 5. And 5 is easy because it only has two factors, 1 and 5. And 1 plus 5 is equal to 6. So this would factor to x plus 1 times x plus 5. And we could check our work by distributing it back out. So this one, x squared minus 10x plus 21. Oh, and notice when we say factor, that's the verb that means break it down into two factors. So different from solving, which is find what x is. See, we have an equal sign on number 3, the second number 3 apparently, but we don't have an equal sign on the first number 3. So anyway, factoring x squared minus 10x plus 21, again, let's list out all the things that multiply to 21. So we could have 1 and 21, and 3 and 7, and that's it. And notice all of these things could be positive or negative. So all of these would have plus or minuses. So the pair that would add to -10, well, if I'm multiplying to a positive and adding to a negative, that means that both of these are to be negative. So the pair would be -3 and -7. So these factors would be x minus 3, x minus 7. So now solving. So solving just, it has one extra step, right? First we have to set it to 0, because we can't use that zero product property if we don't set it to 0 first. So I have to subtract 24 from both sides. So once I do that, I get x squared plus 5x minus 24 equals 0. Now I have to find numbers that multiply to -24 and add to 5. And since it's going to multiply to a negative, I'm going to need one negative number and one positive number. So my factors of 24 would be 1 and 24, 2 and 12, 4 and 6, or I skipped 3 and 8. I think that's all of them. And so since I'm looking for a plus 5x, that means these are going to be my negatives, and these are going to be my positives, because the resulting coefficient is positive, so my bigger number is going to be the positive one. And you can see right here, the pair I'm going to go with is 8 and 3. So this factors to x plus 8, x minus 3. Which means now I can split it up and I get x plus 8 equals 0. And x minus 3 equals 0. So x is -8, or x is positive 3. And one more on the front here. We've got x squared minus 16 equals 0. Now I know what you're thinking, Mr. Trenfield. There's no b term. There's no middle term. But what if I told you this was really x squared plus 0x minus 16 equals 0. All right, because it is. 0 times x would be 0, and it would give us x squared minus 16 equals 0. And now we can see that these are really easy to factor, because this always is going to factor to the square root of this number, because it has to be the same number, right? So 4 and -4 would be the numbers that add to 16 and multiply to 16 and add to 0. Which means our two solutions are our two resulting equations are x minus 4 equals 0, x plus 4 equals 0, so then x equals 4, or x equals -4.